Welcome back to Bradley Aviation Maintenance Channel, where we break down aircraft maintenance in a way that makes sense. We're diving into aviation hydraulic fluids, including what they are, their categories, and why choosing the right one is crucial for aircraft performance and safety. Let's get into it. What are aviation hydraulic fluids? Hydraulic fluids are the lifeblood of an aircraft's hydraulic system. They transmit power, lubricate components, and provide anti-corrosion protection. But not all hydraulic fluids are the same. In aviation, hydraulic fluids fall into three main categories. 1. Mineral-based. 2. Polyalfalfin-based. 3. And phosphate ester-based fluids. Each of these has unique properties, advantages, and applications. Let's break them down. First, we have mineral-based, a petroleum-based hydraulic fluid. These fluids, such as MILH 5606, have been widely used in general aviation and military aircraft. Key properties of mineral-based fluids are oxidation stability, resists chemical breakdown when exposed to water, filterability, easily separates water, keeping contaminants out, lubrication, provides good wear protection for hydraulic components, rust and corrosion resistance, prevents metal components from rusting, sludge and foaming resistance, performs well in damp environments, while MILH 5606 has great lubrication and low temperature performance. Its main downside is that it is flammable, which is a concern in aircraft fire safety. Next, we have polyalfalfin-based fluids, a more advanced category that offers better fire resistance than standard mineral-based fluids. Example: MILH 8328 to fire-resistant hydrogenated polyalfalfin-based fluid used in military aircraft. Due to its improved safety properties, more flame retardant than MILH 5606, red in color just like MILH 5606, and they are interchangeable. Downside: higher viscosity at low temperatures, meaning it doesn't flow as easily in cold conditions. Lastly, we have phosphate ester-based fluids, the most fire-resistant type, commonly used in commercial transport aircraft. Example: Skydrol MILH 8446. Skydrol is purple in color. As previously stated, is extremely fire-resistant. Its high ignition point helps prevent fires in case of a leak. The downside: Skydrol absorbs moisture from humidity, which can degrade performance. It is also irritating to human skin, causes a burning rash if it comes into contact with skin. Always wear gloves and goggles when handling Skydrol. Modern phosphate ester fluids are Type 4 and 5. Type 4 hydraulic fluids are used in landing gear, braking, flight controls, and thrust reversers. Features low density, valve erosion prevention, and deposit control. Type 5 hydraulic fluids are a lightweight fluid designed to reduce fuel consumption and primarily used in military aircraft, as well as small private and commercial aircraft. Let us discuss the importance of viscosity in aviation maintenance. One of the most critical properties of hydraulic fluid is viscosity. Viscosity refers to how easily a fluid flows. Why is viscosity important in aircraft hydraulic systems? Proper force transmission. If a fluid is too thin, low viscosity, it may not generate enough hydraulic pressure. Lubrication and wear protection reduces friction between moving parts, preventing excessive wear. Temperature stability. Must flow easily at low temperatures but not become too thin at high temperatures. Pump efficiency. If viscosity is too high, the hydraulic pump has to work harder, increasing wear. How is viscosity measured? Viscosity is typically measured using a viscometer. In the U.S., engineers commonly use the Sable Universal Viscometer, which determines the time it takes for 60 cc of fluid to pass through a small orifice at a standard temperature. 1 OOF, hydraulic fluid selection and maintenance. 1. Compatibility is critical. Never mix different types of hydraulic fluids. This can cause system failure. Always use the fluid type specified in the aircraft manufacturer's manual or on the reservoir instruction plate. 2. Fire resistance, fire point and flash point. Fire point, the temperature at which a substance gives off vapors that ignite and sustain combustion. Flash point, the temperature at which the fluid's vapors can ignite. Aviation hydraulic fluids are designed to have a high flash point to prevent ignition. 3. Chemical stability and longevity. Hydraulic fluids must resist oxidation and remain stable under high temperatures. Exposure to excessive heat shortens the fluid's lifespan, leading to deterioration. Final thoughts: hydraulic fluids are more than just liquids. They are a crucial part of aircraft operation and safety. Choosing the right hydraulic fluid can prevent system failures, reduce fire risks, and ensure smooth operation. Remember, always follow the manufacturer's recommendations when servicing hydraulic systems. If you found this video helpful, hit that like button and let me know in the comments what other aircraft maintenance topics you want to see next. Thanks for watching, and I'll see you in the next video.